Okay, so what you're looking at is a circulating pump, or if you like, recirculating pump. This recirculates the hot water in my gas boiler, and it has a speed control. Right now I have it set to medium. You have high, medium, low. So that's what I have it set at, medium. And if you are in a power outage situation, and if you want your backup batteries to power your heating, what you could do is you can plug your backup batteries into a transfer switch. There are other ways of wiring this you can see on the internet. So I have the transfer switch set up, and you can use those batteries over there to power this gas boiler. And if you set the circulating pump at medium or lower, you immediately save maybe like a quarter to a third of the power needed to run the gas boiler. Same thing for gas furnaces. They have a gas blower and they have a fan control relay, and they have the blower motor that can run at high speed, medium, and at a lower speed. So what you could do is to set the blower motor to run at a slower speed. If you are on, generally the AC is running on high, the black wire is for that high speed, and you can check to see your heating blower speed. It could be blue, which is on the high side, and then you have the yellow and red going to the lower fan speed. And by lowering the fan speed, you can extend the runtime of your batteries by maybe like a quarter to a third, because that is like turning your blower on high. Of course, it's going to use more electricity. Now, when you lower the fan speed, then of course your house is not going to be warming as quickly, but that's okay. I mean, you still have the hot water, and if you have a gas furnace, depending on how high you set the furnace, you're still going to have heat. The only thing you have to be aware of when you have a gas furnace, you just have to make sure that you don't set it to too low, and maybe if the heat exchanger doesn't dissipate enough heat, you can damage the heat exchanger. But a lot of times these are set to run at very high speed. So this is the fan or the control relay for the blower motor. You have, this is a typical one on gas furnaces. This is a good one. You have M1, M2 here. These are just places where you put the extra wires. So for heat, they might have it on blue, which is like a high speed. On cool, you have a wire that is black color, and that's the highest speed. So what you could do is you unplug the blue wire from your heating control here, and you put a low speed wire, maybe a yellow wire on here, and then you take the blue connector and put it on either one of these spare terminals here. This is just so your wire is not dangling. So you unplug one wire, put it here, you plug the extra wire, yellow or blue, depending on what color you actually have on here. You unplug it and put in a lower fan speed connection. So basically, these wires control the blower motor, and I guess the black wire has low resistance, and then as you go down the red, you have higher resistance, and the fan runs slower. And with the lower resistance wire, you draw more current. So that's why if you change it to a lower speed configuration, your backup batteries will last a little longer. So yeah, so these are 2 kilowatts. I haven't really set up the solar charging yet because I'm in my basement. I have a bunch of cables here and wire. I have to clean it up, and then probably what I do is to run a power port, AC power port outside, and then I can feed a wire in here and make a receptacle here, and then I can plug the cable so I can use AC to charge it. The AC that I'm talking about is AC from my solar setup. I have a solar setup in the garage, and I have an inverter there. So I will change, instead of using DC to charge, I have the inverter feed the receptacle that I'm going to put here, and then you plug this in to do like an AC charge of these batteries. So yeah, solar is a little flaky because you have sun, you don't have sun, and in my solar power setup in the garage, I have a small battery bank that I can use as a buffer to get more consistent output. And if I have AC, even though I have a very small solar setup, it's only 300 watts or so, which is nothing. But if it is a start. So this is basically a backup system, and I'm not using it on a day-to-day basis, although later on I might do so. But initially, that's how I plan to use these 2 Delta 2 batteries. So I thought some of you might be interested to know if you have a smaller unit, something like this, and if you want to run your furnace or your boiler, how you can make it last that much longer. And I think I mentioned on my previous videos, you might have grounding issues with these standalone generators because they don't really have a ground. So if your conduits are not grounded, and if it might not actually work. So you won't know until you plug it in. So right now I'm not going to play with it because my boiler is on. I don't want to make any disruption to it. But if you go around the side of your boiler, you will find that circulating pump there. And yeah, it uses very little electricity, 0.5 amp to 0.75 amp. And the control board uses just a very 10 watts or so. And then the gas valve uses very little electricity. You can run the whole thing for under 100 watts. So the water heater doesn't require any electricity. So you can theoretically run your heating system with something small like this. This I just put it wherever I need to use this. This is sort of like a Johnny on the spot power source, and I have extra ones over here. This one has a smaller inverter. You don't always need a huge inverter. It's good to have a pure sine wave, but if you're just using it for lighting, this is fine. If you have a big inverter, just the inverter itself will draw like 10 watts. This is probably a lot less. And like I said, these I might eventually put these on the shelves together with these other power units, because you can use this to charge these two. So, all right, I am a little windy, so that's my video for today. Thanks for watching.